Okay, the recording started. Now let's share my desktop with you. All right, so now let me open up the homework question. I think it's on week 6 outline, right? Yeah. Okay, so here, so now let's look at the question. Hands-on question. Does the following table, I don't know what is this, hands-on, okay, I think it's just incomplete sentence. So does the following table conform to the third normal form? Explain the reason. If not, decompose it to the third normal form. Okay, so now there's a question. This question is a little bit tricky here. It asks you to check third normal form. However, to conform to third normal form, you have to make sure that it is first normal form first. Okay, so first normal form is not a problem because you do not see any cell with multiple values here. Okay, does everybody see that? No column has multi-values. Multi-values is just one cell has multiple values. For example, for each name, right? The multiple street address or something like that. So there's no such thing like that in this table. So therefore, this table should be found with first normal form. Okay, and plus this table should have primary key, right? So what is the primary key? Social security number, typically use ID, right? And then ID and account number. So those will be ID columns. So you're looking for those ID columns. So in this case, social security number alone cannot be primary key because you see that the value repeating, right? Account number alone cannot be primary key either because you see that 805 repeating, okay? So therefore, you really have to use both columns. Okay, now you check both columns, say whether they will forming a primary key. I believe so because name, street, city depends on the student social security number only. The balance depends on the account number only. So therefore, all other columns depends on these two columns. Okay, so if you make those social composite primary key, then it should be okay. I did.
Your audio keeps on cutting in and out. I don't know if you're talking right now.
Okay. Do something dramatic. Let me change that. USB audio device. Can you hear me? All right, let me go to here to test. All right, everybody, can you hear me? My side shows okay.
We can hear
Can
you.
you hear me? What's happening? Nobody hear me?
We can hear you.
We can hear
Huh.
you.
All right, let's test again. Can you hear me, everyone?
We can hear you.
You can hear me well, clearly?
Yeah.
Okay, all right. So this is the technology stuff. Sometimes not reliable. All right, so I'm going to do the hands-on question again. So based on what I just said, the primary key for the table is, so I'm going to write a primary key, which will be social security number plus account number. Okay, one more thing. Even though you know the concept, this is a primary key, but I still have students call this as two primary keys. This is not two primary key. It's one primary key consisting of two columns. Yes, question. So we are looking at second normal form because we have to check first normal form first and then second normal form next before we reach the third normal form. Okay, make sense? All right, so let's say the PK is that, and then we can, so now we say this table already formed the first normal form because it has primary key, it does not have repeating values, and now we need to do second normal form. For second normal form, then we're going to say whether there's any partial functional dependencies. I believe in this case we do. So let's draw the functional dependency diagram on here. So I'm going to see that consists of the name column, social security number column, street, city, account number, and the balance. Okay, so we understand that this is going to be a part of primary key. This is going to be a second part of primary key. And then for that, I'm going to say this social security number will determine street, determine city, right? So if you know social security number, then you should know the customer well, right? You should know what the customer name is also. All right, and then secondly, if you know account number, then of course you should tell what is the balance for that account, right? So both functional dependencies are partial functional dependencies, they're partial dependencies because those are the columns that depend on only part of the primary key. So these are so this table. So we write that here. So the table is not in second normal form because of partial functional, let's say FD, okay? Partial functional dependency as follows. So what are these? We have social security number determines N, determines street, and city. Okay. Move up here. Then we have account number, determines balance. Okay, so basically based on these two partial functional dependencies, then you make judgment. All right, so this is the second step. Now, third step, how do we fix? Okay. How to fix? Okay, so how to fix for second normal form violations? First step is you're going to write every part of this primary key. So this has only two parts, two key columns. So you're going to write each one of them one time. Social security number, account number. And don't forget to put the whole thing together also. So this every part, okay? So you can just think of like So you have only two things, then what are the parts? So each one is a part, right? And every two also a part. If you have three, then it's more complicated. You have every two, just different combination of every two parts, and then all three together is also a part, okay? A part in that case, of course, just like a whole, but you still have to do that. So then we will have to put together a social security number and account number together. Okay, and then after that, we're going to say what will depend on each part. So the first part, we know that name depends on it. Second one is street. Third one is city. So those are the three columns depend on the social security number. And what depends on the account number? Balance only. Okay, what depends on both? Sometimes you may have something depend on both, but in this case, we don't have anything, so just put nothing in there. Okay, so there we are pretty much done. So now third step is each row a new table. So therefore we make up 3 tables. The first table with social security number as primary key. The left-hand side is going to be primary key, and then name, and the street, and the city. Okay, so those will be non-key columns, depends on a social security number. And then we have account number and the balance. And with account number is primary key because that's determinant. Then even though the last row does not have anything depend on it, but we still have to have a table for that. We understand that is essentially that is a junction table. Okay, and there's nothing besides that, but these two will form a primary key together, and then this table has only primary key columns and nothing else. So this is essentially like a junction table in here, right? Okay, so that's how we end up with 3 tables after fixing second normal form violations. Because the question asks here for third normal form violations, so we should not stop, okay? We have to check again. So I can tell you that this one is already a third normal form because there's no non-key columns, okay? And this one is also third normal form because it has only one non-key column, right? We talk about shortcut, right? The shortcut is if a table has only one or no foreign key columns, then the third normal form is guaranteed. If it's already second normal form to begin with, okay, you have to have the second normal form first, and then check say whether you have only one non-key column or 0 non-key column. So in that case, so these 2 tables will be already third normal form. But then we have this situation here. We have 3 non-key columns: name, street, and city. So they somehow depend on each other. So for example, a student say, if I know the name, can I know the city? The name is customer name. If I know, no, that's not possible, right? So for example, if I know John Doe, how do I know which city he lives? There are many John Does, right? Okay, what about street? If I know the street, can I tell the city? Because many cities have the same street names, right? That's not possible. If I know the city, can I tell the street? No, it's also impossible because city has many, many streets. Okay, so functional dependency has to be unique. Okay, so if you know the city, you know that for sure that what is the name of the street. Then you have functional dependency. But in this case, we don't. We do not have any functional dependency among name, street, and the city. So therefore, this table is already third normal form. Okay, so we can write that. So the above resulting tables are all in third normal form because there there is no FD among non-key columns. So we're using alternative definition on the columns, okay? Or you can say there's no transitive functional dependencies. There we go. So this is how we can do this question. So it's pretty, I thought it's pretty easy. Yeah, question. Name cannot be primary key because name cannot be primary. You have to think about the context here. So we're talking about a bank. Bank have many customers, and very likely that some customers will have the same name, right? Make sense? So name cannot be primary key, but social security number is unique for every customer. Okay, social security number cannot be used for student ID, for some other purposes that have nothing to do with financials. So because of security, because of privacy issues. But for the banks, I think they can still use it for social security for IDs. Okay, they do collect your social security numbers. Okay, name. That bring me another question. Say last class we talked about one case that with Thor normal form, we say editor name determines editor form. So in that case, we thought that all the editors' names are unique. So you have to think of in terms of that context. That small is a publisher. The publisher has only few editors. So those editors are very likely have different names, right? So in that case, the name can be used for that context to determine phone numbers, but not in general context like customers, students. If you talk about names for university faculty members, the probably name can be used to identify because it's not likely to have two faculty members with exactly the same names, right? But it's very likely we have two students with exactly the same names, right? So student names cannot be used as ID for name cannot be used for students to identify students, but name can be used to identify, a group of faculty member in the department or in the college, especially I think probably in the university background also. We do not have two faculty members with exactly the same name. All right, so so you have to think in the context. The context is the database is about that bank, and the bank has potentially many customers, and among them, many of them will have identical names. Okay. All right. Any other questions? Yeah. Okay, that's correct. Yeah, that's correct. So don't choose a primary key so if you talk about a candidate key, you have many candidate keys, then do not choose one that has a privacy concerns or security concerns. That's right. Yeah. No, yeah, I won't say that. You just kind of like if you have some others available. Okay, so for example, if a bank creates something like a custom ID, then you should use custom ID instead of social security number. Okay, but I think in different contexts has different meaning here. So here, social security number. I think do you know that bank collect your social security numbers, right? So they have to use your social security numbers to identify you, right? But not in some other instances. For example, if you go to shop to buy things, okay? If they ask you for social security number, don't give to them, okay? All right, any other questions? Now, if there's no other questions, let me see, we have 45 minutes. I want to do one question, which is, I think it's a very interesting one. It is this one, actually. This one. Okay, so kind of like a review of all the normal forms we just studied. Okay, it has first normal form, second normal form violations, and also third normal form violations. So we'll do that. Does everybody see that? This one, this example 6. So you see in my notes, I work out examples, and also I leave some additional examples for you to practice, additional exercises, okay? So you should take advantage of that to try to do some of these questions. So let's do question number 6 here. Okay, so the question number 6, if you look at it here, is about orders, and each order has order date, each order has a customer, right? Customer name, of course, and also customer address, all right? And then the order has multiple items. So now there is a multi-values attribute, and each item has a name, and each item has different unique price, and each item also have a quantity and a subtotal. All those columns are repeating values, have repeating values. And then of course, each order has a one order number, order total, order amount, okay? So that's unique, okay? So that's not repeating this attribute. Order total is okay. All right. So if you understand that each order is made by only one customer, then this order ID should be primary key for all these records, right? So order ID 103 is for this record, 108 for second one, 110 is for this one, right? So so customer ID really does not have to be part of the order ID or the primary key. You understand? All right. So this table violating the first normal form. So we are going to fix that first. Okay. So how we are going to fix? Remember, for multi-valued attributes like this item ID, item name, all that. Okay. We have to handle that as weak entity. So if we're going to do weak entity, then so what does it look like? Let me just do that, okay? So let's create a new whiteboard here. So you are going to create something maybe just called item, okay? It has, let me put the question up here so that you can see what I'm talking about. That's too much. Okay, so let me put this up here. Okay. Yeah, okay. So you see the table, and then I'm going to show how the weak entity will look like here. All right. So I'm going to have item ID, which is not really key for the items, but it's just like a partial ID. Why? Because if you say that this ID 1025 for this television, and also there's another one 1025 for this order. So then this order ID is not a key, right? The order ID is not a key, but it's just a partial ID. Okay, and then we have item name. Item name. Okay, let's just say that's required or not optional, does not really matter. And then unit price. Unit price. Okay, let's just say that is maybe optional or required, does not matter. And then we have quantity, QTY, and let's just say that is also optional or required, does not matter. And then let's say we need one more place to put one more subtotal there. So I'm going to extend that a little bit. Okay. So I'm going to extend that. Okay, maybe there's too much. And then we have a subtotal. Let's just say this is required subtotal. Okay, now let me put this back here. And then we are going to have a strong entity that a weak entity depends on. In this case, will be just order. And then order have order ID, or ID that is key, order date, or date, okay, just trying to simplify that, order date, and let's say that is required. And then customer ID, and then maybe required. This is required. Okay, it's not part of ID. Required, and then customer name. That is that optional or not? Let's say this optional. Let me see whether some columns are optional. Yes, it's optional. And then customer address. Say address. Okay, so then this is maybe optional also. I think I need one more column, which is optional. So I will do that by I'm just trying to get this eraser here. Okay. Okay, eraser. Okay, go back again. So that is auto total, auto amount, auto total. Okay, so then that is a strong entity based on a table, and then we are going to treat that as a weak entity. Like that, right? So that's how we are going to handle these multi-valued attributes. So basically, we are going to take them out and then make a separate table. So now if we're going to make separate tables, what table will look like? Okay, so it's going to look like this. You're going to have, let me do this way. So we are going to have a table for orders. That will have order ID, order date, okay, which is required. Order ID is a primary key here. And then we are going to have customer ID. Customer ID, which is also required. And then we are going to have a customer name. And then maybe optional. And then we have auto. Right, so that will be, was required or optional? Yes, it was, I put an optional there too. So that's one table for the big thing, for this strong entity. And then for weak entity, we have items. So let's do it here. So we are going to have item ID. That's only part of a primary key, remember, okay? Because it is, you look at it here, that is not a full ID because of weak entity. And then order an item name. Item name. Okay, unit price. Was this optional? Unit price may be required. And then subtotal or quantity, there's quantity also. Quantity is optional. So those optionality is just based on, so you can just make judgment based on data in the table. And then subtotals, stop total. Okay, so that was also required, that's required or optional. Does not matter, okay? And now, because of weak entity, we have the duplicated primary key from strong entity to the weak entity as part of, as a part of primary key. So we're going to create a foreign key column order ID, and that's a foreign key, and it's also part of primary key. So basically, this table is going to have two primary key columns, order ID and item ID. So the order ID was primary key for the first table, and now you duplicate that in the second table as foreign key and also as a part of primary key. Right, that's how we handle that weak entities, right? So basically it's the same concept applied, okay? So now essentially this table is broken down into two subtables. These two subtables, so this result, these two tables are result of fixing the first homoform. Make sense? Good. Now after that we have to check. So first normal form is fixed. Now we have to check second normal form. Okay. So now let's check second normal form. To do that, we need to, so you need to know the procedures, right? So first of all, what is the primary key for each table? So for the table, let's just do it here. Okay. Let's do it here. That table. Maybe the primary key is auto ID. The primary key is auto ID. It has only one column. So the second normal form, it is satisfied automatically. Do you remember the shortcut? So the table is in second normal form because of no partial FDs. So partial FD means part of primary key determines other columns. So that's not a problem, right? So now let's do this one. This table, what do we think? What is the primary key for this table? What should be a primary key for this table? Item ID and auto ID, both together, right? So I already said that. So primary key, well, that is auto ID and item ID. So whenever you have this kind of situation that the column of primary key consists of multiple columns, second normal form is suspicious. Okay, so we can check that out. And then let's say whether there's any partial functional dependencies, and easy to tell. Item ID will determine item name. Item name does not need auto ID to determine. Right? So if you know the item ID like SKU, then you know what is item name. And you also know what is unit price, right? You just need the item ID to determine the price. Therefore, this one has a partial functional dependency. Okay, so now let's try and finish this complete functional dependency here. Quantity and subtotal, they depend on both. They depend on what item you bought and in which order, right? So this one, we have to use both of them to determine. So that's how we draw that. Both of them to determine quantity, pointing to quantity, and pointing to subtotal. So this is why this is the primary key. The item ID and the auto ID will determine quantity and subtotal together. But this table is not in second normal form. Okay. So the table is not in second normal form due to partial FD. So partial FD, what is partial FD here? That is item ID determines item name and unit price. Okay, so that's enough. As long as we have any partial functional dependency, then we can make a judgment that table is not in second normal form. And now let's see how can we fix that. Okay, how to fix. So how to fix second normal form? Let's do it again. All right, so we are going to write every part of a primary key, auto ID, and then item ID, and then together, item ID plus item ID, or both together. Okay, and then put the columns that depend on each one. There's nothing depend on auto ID alone. Nothing, right? If you look at the functional dependency, which is your, there's nothing depends on auto ID alone. But item ID determines item name and the unit price. The unit price, the unit price determines item ID and the unit name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the unit price. And the unit price determines item name and the un Then order ID, item ID together determines quantity and the subtotal. So therefore, this function will produce 3 tables. The first table is actually just a 1-column table, which has order ID on it, which has order ID. So basically, you just have 1 column with all the order IDs. Okay, so you probably think, do we really need that table? Yes, you do need that table. You do. Okay. We will see. This table may be able to be contained by other tables, but for now, we will still have to keep it. Question? What? Which one? In the diagram? No, this item is a weak entity. Item is a weak entity for orders. Okay. Okay. All right, so then the second row, we are going to have a table to be produced with item ID as primary key, and then item name, and the unit price. Okay, as non-key columns. And then finally, we have one table which consists of 2 key columns, order ID and item ID, those together as one primary key. And then here, the quantity, subtotal as non-key columns. All right, so essentially that second table, the second table here is the result of combining 3 tables. Result of combining 3 tables. Which 3 tables? Combining orders table, item table, and also the middle table. The middle table is actually the gerund. So if you're trying to draw ER diagrams, the diagram should look like this. You're going to have orders, going to have items. Okay, and then you have a gerund in the middle. So the gerund will have just simply have quantity and a subtotal as 2 attributes. And then you're going to draw something like that, something like that. And then, of course, orders in this case just have order ID. And then item has item name, item ID, item ID, item name, and the unit price. Okay, so that may be optional, maybe required, okay, whatever. So then basically, if you're combining all the 3 entities into one, including the gerund, then you're making a table which has second normal form violations. Okay, so remember, second normal form violations is due to combining 2 tables that have many-to-many relationships, or 3 tables that have some kind of gerund in the middle. Okay, so in all those cases, you're going to violate the second normal form. All right, so now we end up how many tables? So we end up with 3 tables already. We have 1 table here, 1 table here, 1 table, okay? By breaking down the second table, that's a weak entity table, and plus the original table about orders are still there. So we have 4 tables already, right? So including this table, let's just put this down, okay? Order date, customer ID, customer name. So let's put that. And now we end up with 4 tables, including this order ID, trying to improve handwriting on this small tablet. And then order date, okay, may be required. And then customer ID, customer name, customer address, and then order total. Okay, and then with primary ID as a primary key in this case. So this table is already in second normal form, we said. Okay, so now after fixing second normal form, we end up with 4 tables. Now this order table, you see that is actually contained in here. We will see. Okay, so now we continue. So we are going to check third normal form violations. Third normal form violations. To do that, there's no need to check this one because this one has no non-key columns, right? And then we're going to check the second table. This item ID has item name and the unit price. So we have 2 non-key columns, item name and price. Do they depend on each other? If you know the price, can you know the name? If you know the name, can you know the price? Neither. So this one is fine with third normal form. Okay? And now what about this table? This table has 2 non-key columns also, quantity and subtotal. If you know subtotal, can you know the price, quantity? If you know the quantity, can you know the subtotal? No. So this table is already fine, so with third normal form. Okay? Does it make sense, everyone? So that's how I analyze. So usually if you check second or third normal form, just check this non-key column to see whether there's potentially one non-key column depends on another non-key column. So now let's look at this table. We have 1, 2, 3, 4, 5 non-key columns. Okay? And then let's say whether there's any non-key columns depends on other non-key columns. We do see that. So customer ID determines customer name, determines customer address. You cannot, that is very clear, right? That's very clear. So we have 4 non-key columns, 5 non-key columns, but then we see that these 3 non-key columns have functional dependency. So therefore, this table is not in third normal form. This table is not in third normal form due to dependency FD among non-key columns. Okay, which one? We have customer ID determines customer name and the customer address. Okay. Now, I hope you understand in this question, order ID is the only thing you need as a primary key for orders. Each order has only 1 customer, so therefore, customer ID does not have to be primary key, right? So you just need order ID as a primary key for each order. Each order has only 1 customer, right? So therefore, the customer ID, if you know the order, you know the customer ID, right? Okay, so now we have third normal form violation. Now, how to fix that third normal form? How to fix third normal form violations? Okay, so the procedure is this. First, you are going to use this non-key column dependency to make a new table. So in this case, customer ID will be transistor. So you have this customer ID determines customer name and customer address. And that customer ID is transistor. So you're going to use that to make a new table. You're going to use customer ID as a key for that new table. And the customer name and the customer address as non-key columns. Okay, so that's just a customer, pretty much is like customer table here, right? This table about the customers. Okay, and then everything else plus transistor. Don't forget the plus transistor. You need to add this customer ID back. So everything else, look at the original table. What was everything else? Everything else was just basically order ID, order date, and order total. That's everything else, right? So everything else plus transistor. Don't forget the transistor. So everything else was basically just auto ID and then auto date. Okay, and then auto, what was it? Auto amount, I think, total amount. Yeah, auto date and then auto total. Auto total. And then there is auto ID as a primary key, original primary key. So that's everything else. Plus, you need to add a transistor back. So that basically you need to add a customer ID here as a foreign key. As a foreign key, you need to add this customer transistor back to here. This was primary key. There was primary key here, but now this part as a primary key. Okay. And there we go. So now this, we end up with two tables to fix the autos table, which violated the third normal form. Okay, so remember third normal form violation. For third normal form violation, fixing the third normal form is not clean. You may have to do it again. So that means you have to check, make sure these two tables, resulting tables, are in third normal form. So let's check. Okay, so let's say we have customer ID, customer name, customer address. So in this case, customer name and the customer address are only two non-key columns. Do they depend on each other? If you know the customer name, can you know the customer address? Of course not. So if I say Zhang Dong, where he lives, no idea, right? What about customer address? If I tell you customer address, can you tell customer name? No, neither. Because if I say the person lives in 101 Main Street, there may be several people living in the place, right? Plus, many cities has that same address, right? So even you put a city and then state back, you still cannot decide whether address will be uniquely determine the customer name. So therefore, this table is already in third normal form. Okay, and now what about this one? So here, customer ID is a primary key, auto total, auto date, auto total, and a customer ID are three non-key columns. Do you see any functional dependencies among these non-key columns? For example, auto date determines auto amount? No. Auto amount determines auto date? No, nonsense, right? And then what about customer? If you know the customer ID, can you determine order date? No. The customer making many orders, okay? And if you know customer ID, can you know the customer total, order total? No, the customer making many orders, each time have a different amount. So therefore, this table is already in third normal form. So, end result, let's check again. So we have one table, which is about orders, this one. And then we have a table about the customers, this is two. And then we have table. This one was fixed, okay? Then we have a table about, what is this one? This is junction table, essentially, right, between auto and item. And then we have a table about, this is number 3, maybe, items, okay? And then this junction table, which is about number 4. So essentially, we have 4 tables. What about this table, number 5? This table, now you can say that is clearly, this order, it just have one column with all the IDs. And we have a table which contains that. You see that? We have this table. This table have not just auto ID, but also auto date, auto total, and also customer IDs. So this table, table 1, contains that table. Does everybody see that? This auto 1, this table, auto table, contains this table. So therefore, this table can now be removed. You don't need this table anymore because this is only small, just table with partial information. All right. So, did I tell you something important here? That is, when you're breaking a large table into smaller tables, you have to look for information lossless. So the breaking down, the normalization has to be lossless. So that means the information has not to be lost. Don't lose information when you break it down. Okay? So affixing to violations to normal form violations must be lossless. In other words, no information in the original table, table is lost due to breakdown. So this is a very important criteria for finding something to fix violations. And then in case somebody will pursue like a doctor's in computer science, you may do a dissertation on these normal forms. And at that time, you probably will remember this. If you propose some kind of normal form, the fixing was losing information, then nobody will accept that. Okay. All right. And let's say we have about 10 minutes. Let me ask you whether you have any questions. Does anybody have questions?
Yeah, I had a question. So going back to the item ID table, I was just wondering why the item name wouldn't determine the unit price. Because if you know the name, the name of it has a price to it.
I think you probably, let's see, where's item ID here? Item ID here. Item name and unit price. So if you say the item name can determine unit price, you probably have to assume that item name is unique among all your items. Is that possible? I know SKU will definitely determine the price, right? But the item name, sometimes, well, it's not very often item names are identical. Do you see any items have identical names but are different items? I have not seen anything like that. Do you guys have that experience? Item names have are the same, but they are different items. Yeah. Yeah. Okay, different colors. Okay, yeah, that's right. Yeah, that's a good choice. Yeah. So item name is, if in that case, item name the same, but a different size, different price, different colors. They may also have different price. That may answer your question.
I gotcha.
You got it? Okay.
Yeah.
Yeah. So the item name probably is not a good, may not be unique. Yeah. Okay. Any other questions? If not, I'm going to just talk about the Boyce Codd normal form. Just basically just give you the concept, and then we'll give you examples when we come back next class. Okay? So let me just go to equals. Equals is already here. So this is a very good example, actually. Number 6, a very good example. Through one table, you go through 4th, 2nd, 4th, all normal form violations. Okay. All right, now let me do. So that's PPT. Okay, enable editing. So let me go pretty much all the way back. So we finished third normal form. Let me just see whether we can start here. Slide show. Okay, so we did that, and we did that. Then, yeah, so I already said that if you're combining two tables which has one-to-many relationships, then you're going to have a third normal form violation. Combining three tables that have a chain of one-to-many relationship. For example, table 1 has a one-to-many with second table has a one-to-many with third table. If combining all three tables, then you're going to have third normal form violations too. Okay, so result of fixed to third normal form violation is not clean. Remember that. And now third normal form, this is actually example, we did that. So second and third normal form together, this is, you see that, just remember one sentence, this once, I like that one. So that basically, that made me just remember this normal form, even though I don't come back to this concept, these topics for many, many years, but I remember this one, I still know, what is second third normal form, okay? So basically, every non-key column should depend on the entire primary key and nothing else. Okay, so that is very, very, very important. Just for you to memorize the concept, to take away with you, after you finish this subject. Okay, boys cut normal form, and this is the normal form I like the most. Among hundreds of these normal forms, these normal forms are probably most meaningful. And we use example to demonstrate that, okay? So the normal form does not depend on the first normal form, second normal form, third normal form to start with. Unlike second normal form, you have to be first normal form. Third normal form, you have to be second normal form. But the Boyce Codd normal form does not say anything like that, okay? Does not require to be first normal form or second normal form or third normal form to begin with. And the statement is very simple. Every determinant in the relation must be a key. So if you found a functional dependency, the determinant is not a key, then you violate Boyce Codd normal form. So no need for any other normal forms to begin with, and no need for identification of primary keys. So that is the beautiful part, okay? And this normal form, you think that does not require first normal form, does not require second or third normal forms. However, these normal forms are stronger than any other normal forms we have seen. It's stronger than first normal form, second normal form, and the third normal form. Okay? And because of that, if you're trying to say what is this normal? Is that first normal form or fifth normal form? No, they are not. They are not a first normal form, they are not a fifth normal form. And so people trying to, maybe they're trying to help themselves to memorize this form, normal form, somehow stronger than third normal form, but it's not fourth or fifth. It's actually, they call this a 3.5 normal form, 3.5 normal form, okay? So it's stronger than third normal form. And I'll demonstrate to you why it's stronger than third normal form, stronger than second or third, fourth, first also, okay? So in this case, just look at, just look at all possible functional dependencies. If you found one that, determinant is not a key, then you see that table has a violation of Boyce Codd normal form. So how do you check Boyce Codd normal form violations? You draw FDD first, and then you check if the determinant of each functional dependency is a candidate key or not. If it's not, then the table violates Boyce Codd normal form. Okay, it's simple as that. Okay, now let me see whether we can just give you a very simple example here. Now a branch has many customers, right? And or you issue many loans, right? So I have a table, let's say, with a branch name, customer name, and loan number and amount. Okay, so if you want to do second, third, fourth normal form, then you have to say what is the primary key first, right? But when you do Boyce Codd normal form, you don't have to. Now let's just see. We can see a functional dependency that loan number determines loan amount. Can you? It does not matter what's relationship between loan and a customer and between branch or with a branch. Then loan number, each loan will, if you know the loan number, then you should know the loan amount, right? So therefore, we have functional dependency that is loan number determines amount. Now you ask a question, is loan number a key for this table? Is loan number key for this table? So in other words, with loan number, if I tell you the loan number, can you tell who is customer? That may be or maybe not. Why? Because some loans are joint loans. Husband and wife, partners, they jointly apply for a loan. So with loan number, you cannot tell who is the customer. Make sense? If I tell you the loan number, you will be able to tell branch name? Okay, that also depends. Depends on whether each branch issue loans independently or not. So if they issue independently, for example, Akron branch can issue a loan with loan number 101, and Fair Loan branch can also issue another loan with loan number 101, right? So then loan number cannot tell the branch. Okay? So therefore, this loan number is not a key for this table. However, this table violates Boyce Codd normal form because we have functional dependency that the loan number is not a key, but loan number is a determinant for function, for the functional dependency. Make sense? So this is a simple concept. I'm going to continue this line, and then I will demonstrate a few more examples how this normal form is superior to other normal forms. Okay? All right, let me just stop here. Let's see whether anybody has the questions. I'm going to stop recording for now.